The garbage patch out there is so big and persistent, that's not going to go away by itself. It's almost looking at your house and you say, I have a dirty house, but if I close the doors, then it's going to be fine. You still need to clean it up as well. So for us, doing that part is essential. And we believe that the power and the impact that the ocean cleanup can make is really in technology. Develop technology, be able to move quickly to address the problem that's there already. But also, it's us also getting the awareness out there that people start thinking by themselves what it is. So if the ocean cleanup look at, but what are we good at and where can we make an impact? It's creating that awareness, backing it up by science and showing how big this problem is, and cleaning up the mess that is already out there.
Welcome to Manage This, the podcast by project managers for project managers. We're glad you've joined us for a conversation about what matters to you in the field of project management. I'm Wendy Grounds, and here in the studio with me is Bill Yates.
Wendy, we've got an interesting theme that you've hit on. I love this. We've talked about saving the rhinos. We've talked about tracking orbital space debris. We've looked at community gardens and food banks, sustainability, and man, have we got a great conversation today.
I am very excited about this one. I have been following this project for a few years now and have been trying to find someone who will talk to us, and we were very fortunate to find Henk van Dalen. Henk is the Director Ocean Project of the Ocean Cleanup. This is a project that is looking to clean up the ocean.
That's it. 5 trillion pieces of plastic that we want to remove from the ocean. That's a big project.
Yeah, we're very excited to hear Henk's story.
Henk, thank you so much for joining us today on Manage This from your remote location.
Thank you. Thank you for having me, guys.
One of the first things I want to do is just help our listeners understand the problem. Can you define the problem for us?
So within the ocean cleanup, we're focusing to clean up the oceans. And that first of all means we need to close up the inflow of the oceans, taking the plastic out of the rivers, preventing it going in. But there's also the element of a lot of plastic being out there in the ocean itself. And that's been accumulating there over decades. And our focus primarily is now on the Great Pacific Garbage Patch. So that is the area of the ocean located between Hawaii and California. And there's a plastic soup, you could say, floating around, which is twice the size of Texas. So that is an immense amount of plastic, and it's not going away by itself. It's persistent, it's been there for years, and it will stay for decades longer if we don't do anything about it. And we're talking about, 1.8 trillion pieces of plastic, which an accumulated weight of, we believe, is around 80,000 tons. And of course, if no one cleans this up, this is going to be smashed into smaller pieces by the natural elements. It will end up in our food chain. It could end up on our plate. And it really is just harming the whole environment together. So within the ocean cleanup, our mission is to get all that plastic out of the ocean.
Can you describe how the ocean cleanup began, how this project actually started?
The ocean cleanup is called the child of our founder, Boyan Slat. He was about 16 years old when he was diving in Greece, a great hobby of him. And during that diving, he saw more plastic than fish. And it really started to bother him. And he thought, what can I do as an individual to address this? So he did go to university, but quickly he thought, I want to give all my attention to address this problem. And I want to put full focus on that for my future. So he basically did that. And in 2012, he went online with a TEDx talk, the first one about promoting his feasibility study about how he could clean up the ocean. And the idea was kind of born that plastic washes up on all these inhabited islands where no one is, but yet there's plenty of garbage on the islands. And can we not build something that can act as a natural barrier, basically similar to an island, can capture that plastic? So with that idea, he went public with it during TEDx. He gained quite some attention from that. And in 2013, he received enough funding to start off the research and development, understand more about the problem as well, but in parallel start thinking about the actual technology, how to address this. So it's now 2020, of course. So for a good 7 years, his team has grown. The whole project has grown by itself. It started very much at really researching a problem, like what type of plastic is out there, how does it get there, how does it behave, how big is it? And all this research we've done, we've also publicized via our website. But with gaining the understanding of the problem, we could then start working on the technology to address that. And that's what we've been doing, call it more or less for the last 4 to 5 years. Really, doing a lot of R&D, a lot of testing, and then for making sure that, we come up with a solution to do this. Because in the end, Boyan said for himself, by 2040, he wants to get all of this plastic out of the ocean. So that's our mission.
That's a phenomenal goal. That's such a huge task. Henk, how did you get involved in this? How did you come to join the project?
Well, myself, I have a background in meteorology and oceanography, which is great, but it mainly learned for me where to surf good waves, because I'm a very fun wave surfer. So I actually traveled the world quite a bit doing that surfing, and I remember, I don't know where it was, I think it was in Costa Rica, I read a slogan somewhere that it said, "Don't destroy what you came to enjoy." And I've always been kind of living that motto, of course, being a surfer, dealing with the natural elements, you have a lot of respect for Mother Earth, but also you notice how other people do not necessarily have that. So I came back. I did start working in a marine construction environment, mainly focusing on building offshore windmill parks. But I always thought I wanted to do more directly for the ocean. And it was then that the ocean cleanup, which I was following for a while, actually professionalized quite a bit. And they were then looking for a project manager. So that was the unique opportunity for me to combine my passion, being, surfing and caring about the ocean, with the skill set I built up during those years in the industry, and therefore, make a difference for the better for the future.
That's phenomenal. I didn't realize there was that connection as a surfer and having that passion. It's wonderful the way that worked out. Hank, can you explain further? There's a big nasty name for the first garbage patch that you guys are going after. Explain how many there are in the ocean, how many big accumulations of plastic there are, and then why did you guys pick the one that's between Hawaii and California?
So if you look at the world's ocean, there's basically 5 big gyres, and that's where kind of ocean current circulates around, but you end up in a kind of calmer area in the center where a lot of debris then accumulates. So those 5 gyres are basically in the North Pacific, and that one is the one we call the Great Pacific Garbage Patch. There's the South Pacific, the North Atlantic, the South Atlantic, and there's the Indian Ocean. Yeah, as I mentioned, the plastic accumulates there because after a while it kind of is released by the ocean currents, and then it starts to stack up over there. So of these 5 gyres, we have investigated the North Pacific one, because it is known that that one is the biggest, the most persistent, and therefore also the most worrying in that respect. And also for, call it a young startup, we've grown quite a bit, of course. We're not necessarily a startup at the moment, but for us to really get a focus and tackle the problem hands-on, we said for ourselves, let's grab the biggest one first, and that is the Great Pacific Garbage Patch. Let's make sure we develop technology to address that, and that should be scalable, that we could also deploy this on the other gyres in the world. But first and foremost, let's tackle that the North Pacific one first.
When this project started, there must have been a lot of testing, a lot of feasibility studies just to see if this was going to work. Was there ever a time through the process over the years that people kind of felt, this is not going to work? I know there's been a lot of negativity from people outside looking in, but did you guys ever feel, whoa, maybe this isn't going to work? Or were you always just, this is the right thing?
First and foremost, yes, we do face a lot of challenges, and there's a lot of setbacks because of that. I think the challenge what the ocean cleanup has in general is we're doing something that's never been done before. It's similar to what it says at our website. It is the biggest cleanup ever if we achieve it, and we will. But it's also the challenge that you're operating a space where you have no example. You can't just look at, the fishery and say, I'll copy that, and then we're there. It doesn't work like that. So what we've been doing is, like you mentioned, very extensive R&D, but very much a lot of testing, making sure we validate the hypothesis we have or learn from it and build upon that knowledge. And with that also comes a lot of setbacks. And I think if you look at the history of the ocean cleanup, it quite nicely also shows how we have matured as a company. So initially there was a feasibility study which had a 100-kilometer long barrier more to the seafloor. The idea is very good. But then, of course, you get to how are you going to execute, maintain, build this whole thing. Then the challenge, of course, is very big. Then we moved to a system which was more propelled by natural forces, and we start building upon that. And with that kind of concept fixed, we started going component testing, learning more about also the behavior that waves have on the system and how it interacts with plastic, and step by step increasing that learning. And I think the one thing we have, maybe coming back to your question, is we've had a lot of challenges, and the way we deal with that is always as a team. The one thing we share is our passion for the ocean. It's without doubt that we all want this to happen and want to make it happen for 100%. So every time there's a setback, there's also a moment of reflection, bringing it back to the mission. What are we trying to achieve? And then, are we still on the correct path? And don't necessarily see every test as a failure, but more as a beautiful learning to know maybe how something doesn't work or what elements you can get out there to make sure you benefit from that. But that does mean that, it's a dynamic environment you work in, and you have to definitely keep that passion and strong will together as a team. But in the end, therefore, we will succeed.
I can sense the passion in you as you describe this. I'm sure for the teams to sustain the momentum required to take on this huge task, you've got to be like-minded in that. So let's talk a little bit about some of the processes, some of the steps where, because you guys have really evolved. When you look on the website, you can see, okay, this is what we tried first, and we learned some lessons from that. Then we tried this, then we learned a little bit more. Just walk us through some of those, maybe some of the highs and lows from some of those things that you learned.
So, as I mentioned, we started off with a feasibility study. That was way back then. I've been with the ocean cleanup for about 2.5 years now. So a lot of that is also a very small group of engineers trying to figure out things together. But the feasibility study was a good way to get the idea of the ocean cleanup started. And then more and more engaging with the offshore community as well. So there's a lot of marine-minded companies who also support this mission. You get their feedback, you fine-tune your ideas. And quickly, that moored barrier to the seafloor, that changed to a system which was free-floating. And what you then get is, first of all, a lot of engineering needs to be standardized almost, you would say. So there's not a model you can grab and use that. You have to use existing models, tweak them for you, and start to validate that. So the engineering kicked off, but also the validating the results from the engineering by a lot of model testing in that case kind of helped us to fine-tune that part, that more and more we could gain understanding also by using the models and validating them in the correct manner. And then you saw during the model testing period that actually the interaction between the plastic and the barrier, the waves, the wind, it's very complex. And in order to model that all correctly, you then could be busy for decades, if not longer, before actually achieving what you want to. So that was also an important realization that we said, if we want to achieve this in the timeline which we have, and we do feel the pressure because the stuff is out there and it needs to be cleaned, that garbage, then we also need to dare to make bold steps that if we think we've done something good, then let's go out and test it. Maybe accept that it's not always good enough, but it's good to gain more momentum and learn from it, and therefore proceed forward. So after a lot of scale model testing, we then actually started launching a few prototypes on the North Sea. And this was mainly seeing, okay, we want a floating pipe basically on the sea surface. And below that, we want a skirt, which basically prevents plastic from flowing underneath. Now, a big challenge is that the skirt wants to be flexible. You want it to move it with the waves, yet you want it to be rigid enough that it stops the plastic going underneath. So there's a very lot of contradicting parameters you have there, and therefore not just one material that stuck out. So we tested various materials offshore, had quite some setbacks there as well, like really learning that we thought we had a eureka moment, and then you test it for 2-3 months and it turns out to be the wrong thing. But every time, like I mentioned before, putting those learnings into positives, making sure that you gain from that and think about new things, new opportunities, that worked very well then. And that really allowed us to make the big, bold step, you could say, to launch our first system after those North Sea tests. And that system was basically launched from San Francisco in 2018. And we named that system Wilson, to give it a nice name after the Castaway movie with Tom Hanks.
Okay.
So Wilson for us was a big step. We did a lot of testing before that, a lot of engineering, but we also knew that we needed to make the step of Wilson to really start the cleanup and continue the momentum we have and the learning curve we were in. And a lot of things went well with Wilson. It also showed as a team how we could get together, use all these new materials, all this new type of thinking and design, and actually get a system together which is, operates offshore and is solid enough to withstand wind and wind waves. But we also noticed when we had that thing operational out there for 3 to 4 months that it wasn't perfect. It was capturing plastic, but plastic was also released at times. It was behaving well with the models. That was very positive. But we also experienced a structural failure after 4 months. A piece of the pipe actually broke off. And afterwards, we did a whole root cause analysis and actually could figure out why that was, why that system broke. But on the other hand, looking back, we couldn't have known that any better or sooner without making this step. And I think that is what we're constantly trying to do is challenge ourselves and definitely think with risks in our mind, but also dare to be bold enough to make that step to get out there and learn. And with Wilson out there, we had a few positive things which we could build on for our next system. And that's the one we launched last year. We called that System 1B. So again, using the positive elements of Wilson, but tweaking it such to overcome the parts that didn't perform too well. And that resulted that last year we actually had a system which was successfully capturing and holding plastic and really confirmed for us like, okay, this technology approach we're taking works. Now let's scale this thing up and let's make it durable that it can last out there for years upon end so we can really start this cleanup full scale.
Henk, I have a follow-up question related to that process because I think it's something that a lot of project managers can relate to, which is we're going to create a prototype, we're going to put it out in the wild, in this case in the ocean, and we're going to see how it performs. We don't expect perfection. We prefer speed. We want to quickly get a prototype out there, whether it's a product like you guys have, a solution, or even a web page. We just want to see how it performs. We know there are going to be issues with it, and then we're going to tweak it and we're going to put another one out there. What I've seen myself, and I know other project managers struggle with it at times too, you have really bright people that are speaking into that prototype. And sometimes they're very passionate about it or feel very strongly about one technology or one choice. So then there gets to be a bit of my identity, assigned to that. So then it's hard for me to look at it and admit that it's failed. So we put the prototype out there. Maybe I was really pushing for, you talk about the floater, one particular material. I really kind of staked my identity or my reputation on it. And then we look at the facts and it's like, okay, that's not the best choice. It should have been this other one that Henk had suggested all along. From a team standpoint, how do you guys overcome that sense of pride and continue to move forward as a team in a healthy way to be sure you get the right lessons learned and move forward properly?
That's a good question and a big challenge with a lot of companies in innovation, I guess. You're very proud of call it your baby you make. You want it to perform well, and if it doesn't, that could hurt as well. I think within the ocean cleanup, a very important part is that we are, first of all, again, coming back to the mission, the passion, we're all in it for the same thing. We're all like-minded in that sense. And that also allows for the fact that if something doesn't work out the way it should have or whatever, it's not a blame culture. It's more thinking, well, we put our heart and soul in this. We gave it a good thought. There was good reasons why we do this. We do always make decisions based on data. It's not just always gut feeling. It makes sure you run the numbers as well and keep the rational part going. But combine that with passion, then you get to great things. And I think within the ocean cleanup, we've never had a blame culture. If something goes wrong that you pinpoint it to someone, it really is then changing the mindset again. Okay, it didn't work. Damn, it hurt. Let's, we can grieve for a little bit. But after that, we pick up and we really start to evaluate, okay, what were the learnings out there and pick up from there. And one thing we have within the ocean cleanup is that there's a lot of clever folks there, and a lot of them are relatively young sometimes as well. So it's their first job or their second job. So there's also a very important part for us as managers to make sure we coach them correctly and also give them freedom that the work is theirs. They have a level of input and a healthy level of curiosity that we always want to understand what they're doing, what's going on, but keep coaching them in their expertise. And I have seen for myself that almost always that results in great things. There's little things that I look back on and say like, oh, that was completely wrong, or we should have done that different. There's always learnings that come out of it that wouldn't have happened if you would do it on a very controlled top-down type of manner. So I think that's also the power of the ocean cleanup, to build a group and really give them the space and the opportunity to grow and really do amazing things that no one's done before, because that's what we want to achieve. And that's the way to do it for us.
I just love that. And just looking at how this has developed and what you guys are doing, it started with a vision from a very young man, and people could have just said, we're not listening. But he surrounded himself with people who are smart. He's surrounded himself with a good team. And if you have a good team and you got that passion and the drive to get this done, and then getting good sponsors on board as well, and getting the story out there, and like you say, just tweaking those techniques, learning from your testing and just continuing. So I'm excited to see what you guys are going to do. This is a story I've been following, as I told you earlier, and so this is just making me think, wow, you guys are really going to achieve some great things. I want to go into a few practical things. I know that people are probably wondering about the plastic. What is the size of the plastic that you're collecting in the floater? And when it comes to the barrier, does it stay in there? What keeps it within the barrier? And how deep is that skirt?
Yeah.
So to bring it back to 1B, the length of the pipe was basically 140 meters with a diameter pipe of 60 centimeters. Now that was actually downscaled quite a bit from Wilson, because Wilson being the first system which we had out there. And the reason we did that, because we wanted to fast track 1B out there, because we knew we were on the good path, but we needed to do better. So then we said, okay, let's minimize the, call it, design requirements. For the summer months only, it needs to be modular so we can tweak it offshore. But if you look at the full scale time to develop, it's maybe better to pull it back to the Wilson system, because Wilson itself was 600 meters in length. Oh, you have to help me a bit with feet here. That's about 1,800 feet.
Yes.
And the pipe diameter was 48 inches, to bring it back to American sizes. The idea is that when we're offshore, we tow this pipe in a straight line out there. We then close the system with a set of lines, which basically allows this straight pipe to go in a U system, in a U shape. And the U shape is then deployed offshore. And at the bottom of the pipe is a skirt connected. It's a flexible material which sits about 9 feet deep. Now, the idea of Wilson was then it was pushed forward by the wind and waves acting on the pipe. So it's actually being propelled forward with the idea that it could overtake the plastic, which is not so much sticking out of the ocean, so it goes slower. So then we overtake the plastic and it's all centralized in the middle of the U shape. And then at times we can extract that. And the beauty of the skirt sitting below it with its 9 feet would be the fact that plastic is in there and it's buoyant enough to stay up there. Yet the marine life can just dive a little bit deeper and go underneath. And also for marine life, the system travels relatively slow, say 1 to 1.5 knots. So it's not a big danger for them to get entangled by any means. The one thing we had with Wilson, though, it was going a bit too slow at times. And also it lost speed when the wind kind of drops, which we knew would happen. But it turned out that the plastic would then be overtaken a bit by the Stokes drift. So kind of the plastic moves with the wave moments and then therefore escape the system. So when we moved on with System 1B, again, we scaled it down and we said, okay, let's see if we can go quicker than all types of plastic during all times, or if we can turn around and go as slow as possible, that the plastic always goes quicker than us. And that probably relates to the question you have regarding the size of the plastic. So when we look at all the stuff that is out there, basically on the largest end of the spectrum, you have it's almost half of the stuff in percentage in weight. Those are ghost nets. And this is abandoning fishing gear, fishing lines, nets. It's all entangled and they can get very big and very heavy, but they move very slowly through the water because of their weight and size. Now, on the other side of the spectrum, you have the very small microplastics. Now, to focus our technical capabilities, we said, let's aim to catch everything from 5 to 10 millimeters and above, because often the smaller microplastics lose their buoyancy and then the water depth there is 4 to 5 kilometers. So to capture that all, that's challenging. What we want to do is capture it before it becomes microplastics. So we have this range of, say, millimeter-sized plastic to as big as ghost nets, which can get into any size. They can get quite big, so in tons in weight, but also quite big in size. So when we said, can we speed up and go overtake all types of plastic, that means we had to go faster than the fastest type of plastic. So that's the small plastic moving with those wave forces going forward. If we can overtake them and capture them and hold them, we're in a good sense. But if we turn around and go as slow as possible, then we need to also be able to capture the slow plastic, being the ghost nets. They need to travel quicker than our system. So when we were out there with 1B, we actually had the joy and the luxury of that both systems were actually working. So we could go quicker than the quickest types of plastic and slower than the slower types of plastic. So that proved that the thinking of Wilson was good. We just needed to add in more force and propulsion with it so we could capture all types of plastic. But it also turned out if you slow down that worked quite well as well. So we capture the full range from millimeter-sized plastic to the ghost nets. And the skirt sitting below the pipe, that really goes to about 9 feet deep. And that proves to be deep enough so that it actually captures all the plastic floating on the ocean and therefore accumulating in the center of the system and allowing us to scoop it out.
The goal that I see on the website is 50% removal in 5 years.
Yes.
So this description that you gave of the U-shaped deployment of a netting system, and within that there's a floater net or assembly that's about 9 feet below. So then let's just take the example of the Great Pacific Garbage Patch that you're going after. Yep. How many systems would it take to deploy to reach that goal?
So one of the things we're carefully looking at now is actually to answer this question, to be very honest. System 1B was performing well, but we knew that in size, it wasn't good enough to tackle this whole thing. It was really to make sure that we could prove that the technology and the operations we're proposing are feasible. So call it, we tick that box. And now it's really looking at us, how big can we size this technology that we capture more, but we also want to hold it longer in the system. And then we get a bit to an equation which relates a bit to cost and environmental footprint as well. Because if you can lower your cost per extracted kilogram, there's a whole list of benefits related to that also for the environment, because costs come a lot from vessel use, operation of boats offshore. So if you can minimize that, per definition, also your environmental footprint's coming more attractive. And that's the end, the ocean cleanup. We want to do good for the world. So we understand we're now at the early stage of the technology. But when we get to the full-scale cleanup, it needs to be sound and definitely environmentally proof, I would say, there. So for the future system, the direct number is not there. But we do know that the technology we have is scalable in size. And what we're now engineering a lot, so we've had system 1B. We're now in the office working very hard on system number 2, meaning grabbing the good elements out of 1B and then thinking, how can I scale that in size? But the challenge probably is mostly, how do I keep the plastic in the system longer? Because therefore I have to extract less frequently. And you also want the system to be durable, that it's out there for up to a decade or plus without a lot of repair and maintenance. So those two challenges are there at the moment. Once we've solved that, then we're going to tow out there again with a bigger and improved system, but that should be at the size that we expect that we need to clean up the whole Great Pacific Garbage Patch.
This is so fascinating to me. It's so interesting to think you have a tug or a garbage truck, if you will, that's basically making its rounds to those systems to remove the plastic. So you've already talked about marine life. There's a solution there, especially for the sea anchored system, the slower system. What about if I'm a ship operator and I have a route that goes in that area of the Pacific? How do I avoid ruining your system or getting my propellers caught up in it?
That actually is a big risk in general outside of the marine life we have. There's also the economical impact of this garbage patch, because as you mentioned, if you're out there in the middle of the ocean and your vessel gets caught in a fishing line or whatnot, you're far away from anything, which not only safety is a worry, but also when it comes to the cost of the operation. So looking at all this, first thing we also did with the Great Pacific Garbage Patch is when we wanted to deploy a system, we engaged with the Dutch government to say, okay, if we want to deploy something out there, what are the standards we need to adhere to? Just to get an idea that safety, rates the marine life, but also for shipping navigation, all that stuff. And we quite quickly figured out there, if you do something that's never been done before, there is no guideline, so you kind of have to help a bit there as well. We had very good communication there with the Dutch government and also adding a certifying body to it, a third party. And we kind of said, well, if we take this whole approach, which I'll explain a little bit, would that be good? And then they said, yeah, that's the way to go. And that would help you then build a system which is safe also for marine traffic and that type of thing. So we looked at the Great Pacific Garbage Patch and noticed already, if you look at the trajectory that ships take, there's not many ships in general going through it. So that the risk of actually having a full collision is relatively low by itself. But in order to lower that risk even more is what we do before our operations start. There's a notice to mariners is issued. So they show their transport route. Before they go, they get this warning in there. And we also outfitted the system itself with a lot of electrical instrumentation pods. So bringing it back, what we did is we outfitted our system with quite some instrumentation pods. And part of that was there was instrumentation in there that if ships were to be nearby, then 20 nautical miles, our system would start to pop up on their radar. In addition, if they would get closer, we'd had radar reflectors and lighting on there. If they even got closer, well, then we said, well, last mark we'll do, because we're still testing out there, is we also have a vessel alongside that will also see this ship coming, so we can do a final warning if that even happens. So if you look at that, there were various gates, so limited vessels going anyway. We had marine equipment on the system, which would alert vessels when they get near the system. And therefore building so much defense mechanism that you're basically saying, okay, this system is safe to operate out there, and you're really ticking all the boxes you need to do when it comes to navigational safety.
I have a quick question. What do you do with the plastic? Once you've collected the plastic, where does that go to?
So the plastic is extracted out of the system. It's put on the back of a vessel, and then we bring it to shore. Now, the idea is at shore, we're still in the small scale of operations, but what we do then is we sort it. So you have various types of plastic. So mainly the ghost nets are separated from the smaller rigid type of plastics because they each have their own specialty to be recycled. The parts are then shipped to the various recycling partners we have, and they then make durable goods out of this, which are then marketed under the Ocean Cleanup brand, which will give us income again to make sure we can continue to finance our operations in the future. But the whole idea, of course, about recycling this plastic is making sure it doesn't end up in there again, of course. So the idea really is to make it into a durable product and ensure that it gives something for future use there as well. So the first plastic we've landed all with System 1B, it's in that process. So via our website, you can also sign in if you're interested to understand more about that. And I think in September-ish this year, we're going to reveal a bit more details what the product's actually going to be. But the idea is thinking it into a circular manner, that we actually turn waste into something which is good for the world, but also helps us continue our operations.
Yeah, I think it's a smart idea to keep that plastic from being something that just simply gets back into the system. You think about it, it's like that's what we want to stop. And I know a lot of people are saying we should be working on the source, like where's the plastic coming from? That's where we should be attacking the problem. What are you guys saying about that?
We fully agree. We need to tackle it at all fronts. Let's be very clear about that. I think if you look at the plastic problem, so the way people behave, how we deal with it on land, very important and requires a lot of attention as well. The one thing at the Ocean Cleanup we say is if we don't do anything about it, it's going to get even worse. But also that means preventing it from entering via the rivers. So we have cleanup systems to prevent that inflow. But also the garbage patch out there is so big and persistent, that's not going to go away by itself. It's almost looking at your house and you say, I have a dirty house, but if I close the doors, then it's going to be fine. You still need to clean it up as well. So for us, doing that part is essential. And we believe that the power and the impact that the Ocean Cleanup can make is really in technology. Develop technology, be able to move quickly to address the problem that's there already. But also, it's us also getting the awareness out there that people start thinking by themselves what it is. So if the Ocean Cleanup look at, but what are we good at and where can we make an impact? It's creating that awareness, backing it up by science and showing how big this problem is, and cleaning up the mess that is already out there. That does not mean that the other work is not important, but if we take that on board as well, we're basically diluting our focus a bit. And if you try to do it all, you'll probably fail at quite a bit. So we're saying our focus is here. We definitely support the other initiatives and stand fully behind that. Yet we also realize that cleaning up is essential to tackle this global problem.
One of the things that I've noticed you guys are doing is the Interceptor, I think it's called, the river cleanup. Could you tell us a little bit about that? Because that's an exciting project as well.
Yeah, so the Interceptor, that's been a project that we've been doing off the radar for quite a while. The reason was because, of course, the ocean cleanup is looked at very hopefully by a lot of people, and we wanted to keep the focus on the oceans and make sure we deliver on that promise. But in the meantime, we also knew that we needed to tackle the river, but we thought if we keep that off the radar, then in a bit more quietness, we can really focus on the technology and reveal it once it's out there, rather than also giving a promise. So you're actually showing something that's already working then as well, and then the impact is even bigger. So the river systems were presented to the world last year, and we actually showed that we already built 4 of these things. Now, as you correctly said, they're called the Interceptor. But the idea about the Interceptor is really that if you look at the 1,000 most polluting rivers in the world, about 80% of the inflow of plastic into the ocean comes from those thousands of rivers. So the idea was of the ocean cleanup, if we can tackle them, then we're getting our focus again on the correct place and having the biggest impact. And then start thinking, how can we create scalable technology that this would work? So not having a system which need to be designed specifically for every river, but one that could work uniformly around the world. So with that idea, the Interceptor was born. And the idea behind the technology is that you situate it in a strategic position within the river, meaning that, for example, if there's a bend in the river, you often see that the plastic goes relatively close to the river beds and then goes back to the center. So if you position an Interceptor there, it's a floating pontoon basically with a small barrier, and the barrier then guides the plastic to the mouth of the Interceptor, and then via a conveyor belt it goes up. But if you position them strategically in those areas, you're not blocking the whole shipping lane, because that's a big impact, of course, on rivers. They're economically very important for countries to keep their industry going. So we found that via research, if you could position them there, you have a relatively small barrier. Plastic goes via a conveyor belt up into the Interceptor system. And then all the plastic is distributed over the various bins which are in there. And then the system actually alarms the shoreline when the bins are full. So then you can pick out the pontoon with the bins in it, you can bring them to shore. And meanwhile, the plastic production can continue because the conveyor belt can act as a buffer. So you can empty those bins, bring them back, and then start to continue the operation. Now, very important for the Interceptor is we want it to be autonomous, so it basically can work by itself. So a lot of focus is also bringing on to durable energy, so solar panels on there, all that stuff. But also software that you don't need 100% someone to operate it the whole time, but it can operate there standalone and gives warnings to shore where and when needed. So we've built 4 of these already. 2 of them are already operational, one in Indonesia and one in Malaysia. And we have one ready just to be starting operations in the Dominican Republic. However, unfortunately, during the global coronavirus impact at the moment, that has been postponed a bit. But it's great to see these things already in operation and a lot of plastics being collected out of the rivers.
Henk, I want to ask you about leadership. When I think about, as you've mentioned, some of the youth that you're dealing with on the team, and certainly the passion. I love the ocean and I want to clean it up. I want to be a part of the solution. As I think about that, and I think about the unique technology you guys are tackling, there's a lot of leadership challenges that pop up. So I just wanted to ask you, are there some leadership lessons that you have from your past that have helped you in your current project?
Yeah, that's a very good question. I think the transition for myself, I came from a more corporate background before the ocean cleanup, and then you're very much more driven process-wise. Call it the path from A to B is kind of mapped out. You swirl around the path sometimes, but you get to B. And then you come to the ocean cleanup, and all of a sudden it's from A to, well, we know where we want to get, but there's definitely no path, and then a lot of things to be overcome. So one of the things I always had in the past, which I found very important, is the element of storytelling in the way you present your plans and you want to get people on board. So make sure that from a mission perspective, you really have a good story and can always bring back to that story what we're doing and how we want to get there. And therefore also keep that motivation alive within the team. Secondly, one of the things that I did a lot in my previous jobs, and even more so at the ocean cleanup, is really coaching. And coaching from an element of being curious rather than skeptical almost. So like I mentioned before, there's a lot of good ideas. And of course, I don't understand it all. These guys are much brighter than I am at times. But understanding the bigger scale of the project, you can ask questions to understand more about where they're heading, what the impact is and whatnot. And by having that active dialogue, you're not necessarily restricting the clever stuff they can come up with, but you can coach them to make that fit in the bigger picture and then tie it all together. So those 2 elements have been very important, I think, in the way of working within the ocean cleanup. And in addition to that, I think what is very good, and I'm a big fan of myself, is keeping that element of fun and humor in your work. You asked already a bit about the setbacks you have. If you take everything too serious in life, then yeah, that's going to be a big weight on your shoulders. But also within the ocean cleanup, we have a good sense of humor. We were very leveled across the whole organization. So any joke can be made to anyone, and in a good way as well. And I think that is also what we have, that even in dark times or difficult times, things are against us, we still make those jokes. We still have the fun, the crazy stuff we do. We keep that going. And even much more now, so we have the whole team working at home. Difficult times we can do via online tools keep working, but normally you'd be in a room brainstorming all that stuff. But what we do, for example, is recently we had a brainstorm session and we all entered as a character. So we all dressed up in a certain outfit and just have some fun in the game as well, you know.
So who did you dress up as?
I was the Hulk, evidently.
Nice. Smashing problems. I like it.
Yeah. We're tackling a very serious problem. We take it very seriously, but we also understand that we have to have fun and a bit of lightheartedness in our work to achieve what we want to achieve. And definitely as a manager of the team there, I think it's essential that you also show that to your team. And you can be serious at times, but you also need to have fun.
Yeah,
sure.
You got to let it. Yeah, you really have to flow with it. And it keeps the energy flowing. Laughter makes me more creative somehow. You know, I don't know why the brain's wired that way, but it's just the way it works. Looking back on the project that you've been a part of, what's been the biggest surprise to you so far?
I think the biggest surprise to a certain extent was the challenge we faced when Wilson failed us, or really the system broke. We didn't see that coming. We couldn't have seen it come, but it broke. And what we then had to do was demobilize that system. But immediately we sat together and said, we're on the correct path. We need to build something fast, small scale, and get out there and continue this learning. So there was that kind of element of grief and disappointment, I guess, of having Wilson getting out of the picture, which we put our heart and soul in for a good 2 years. And then this new system, which you really had to push forward and really also push a bit the boundary of engineers, because sometimes engineers are very innovative, at least ours are. And if you put a lot of pressure on them, they get a bit risk averse. They don't necessarily converge, they diverge again in ideas. And then you have the challenge of managing a team under a relatively strict deadline to do something challenging and maybe not done before, but you know the benefits there, but it's very uncomfortable for them. And there was this period within those two projects between them that we as a team were also struggling a bit how to deal with that. So a lot of emotions going around. But again, I think there it was all bringing it back to communication, bringing it back to the mission, focusing again on our passion and letting people speak freely. And some people disagree with the approach, some people do agree. And finding that balance, but hearing the people and bringing everybody together again. And what very surprisingly for me was in that period of turmoil, which was definitely happening within the team, we got realigned. We did 1B out there and it turned out to be a great success. We were all hoping for success, but I guess with Wilson, we're also preparing a bit for the worst. You become a bit skeptical, of course, after setbacks happen. But then it turned out that things capturing plastic, it's holding it, it's going well. Yeah, it was a great moment. So ups and downs there, yeah, for sure.
We definitely are hoping for your success. We're very excited, and I know we're going to continue to watch what you guys are doing and keeping an eye on the ocean cleanup project. If people want to hear more about it, where can they go? Where's the best place to hear more about the Ocean Project?
Well, definitely have a look on our website. So that's www.theoceancleanup.com. And there you can also connect to our various social media channels. But the website itself gives a great overview, I think, about the mission, the past, where we're heading, the rivers, the oceans, and all the updates we keep very much alive via the social media channels. But I think the best part to get the main information is definitely the website there. Keep following us, of course, and any support. I mentioned already, of course, we're bringing the plastic to shore. We're going to make some great products of that. And any support there or to our mission is greatly appreciated and will help us a lot.
The website has great visuals and videos, schematics of how the system works. And there is a way to support the project too. And yeah, I encourage people to go to it and check it out. Henk, thanks so much for taking the time to describe this. There's so many challenges that you're facing with this project that other project managers can relate to. It's overwhelming to think about trying to remove the plastic that's littering our ocean in just a few decades. And we're all blown away by it, and we also have a lot we can learn from it. And we're all encouraged and inspired by that. You've shared a lot with us that we can learn from for our projects as well. So thank you for your time.
Well, thank you very much for having me. Definitely a pleasure. And as mentioned, we're very passionate about a mission. So I give you my word, we're going to continue until these oceans are clean, for sure.
That's it for us here on Manage This. I hope you're taking advantage of the free PDUs, those professional development units, that came from just listening to our podcasts. You can claim them by going to velociteach.com and choosing Manage This podcast from the top of the page. Click the button that says Claim PDUs and click through the steps. Also, please keep in touch by leaving a comment on our website or wherever you listen to our podcast. Until next time, keep calm and manage this.